quiz. And the quiz tomorrow, like I said, is pretty straightforward. I don't think you're going to have a whole lot of trouble with it if you know the angle pair names. If you know the angle pair names, it's going to be the hardest quiz you take all year. Okay? Because you just have no clue as to what to do most of the time. But if you know parallel, perpendicular, skew, you can name lines, which are things from chapter 1 you should be able to do. This should be a breeze. But again, in this first section, this first page, it's really important that you use the correct symbols. Now, as I mentioned before, there is a mistake on the original version of the quiz, which you have, or the review, which you have. It's been corrected on a new version of the review I just got done with. So if you're watching this after 2017, you're probably going to see things be just a teeny bit different on this first page. But what we did yesterday was just said ignore the contains point R, but tomorrow it will actually make you contain a particular point in your answer. So make sure that your answer contains the point that it specifies, and that helps narrow down the number of possible answers. And I think it's just looking for one. The other big thing is make sure if it asks you to name a line, that you name a line. That means you use a line symbol. If it asks you to name a segment, use a segment symbol. If it asks you to name a plane, we don't use a symbol, but make sure you use 3 letters. And it kind of models it for you. Skew to MN, look, it's line MN, and it shows you the line symbol. Or plane RKN, look at that. It says the word plane and 3 9-collinear points. They're listed. That's how we named that plane. Guess how we should name our plane? Probably very similarly, just using different points, right? Yeah. So it's kind of modeling it for you and giving you a clue. So this is really some reviewing of Chapter 1 material along with what we're doing here in Chapter 3. So give me just 2 lines parallel to MN. We won't concern ourselves. Okay. So KL, yeah, that would be fine. And we have to have the line symbol or it's not going to count. QP would be marvelous. We could also do RS, technically. Because there is a plane here, it's just not drawn in. Cutting through that way, isn't there? Okay? So a teeny bit tricky, but yeah, we could actually get a third one. 2 lines perpendicular to MN. This should be pretty easy. You only need to do 2.
1, 2.
Oh, okay. Okay, but how many perpendicular lines containing R are there for MN? None. Okay. If we do it the other way, points containing R that are perpendicular, it's just 1 line. Sorry, it's not going to erase that because that's okay. 1 line perpendicular to MN containing point R. There are no lines perpendicular to MN that contain R, are there? No. Okay. Give me a line that is perpendicular to MN. QN, LM, NK, PM, any of those, but none of them that contain R. But QN would be one example. Okay. 2 lines skew to MN containing point R. Now there are 2 available here. Skew means that they are not parallel, but they don't intersect because they're not in the same plane. So it's like one going up high and one going down low. So QR would be one of them. Okay. No, they wouldn't because they're in different planes. One's down here and one's up here. They're never going to intersect. What would be another one? SP does not contain point R. SP would be skew, but what would be another? RK. Yeah. Okay, and it's going to say that tomorrow on the test too. So.
What if there is none that are like perpendicular?
Yeah, there were technically none that contain point R. Okay. Yes, the test center. The test is better. There was a goof up on that when we rewrote the quiz. You know, I'm always taking the quiz and just rewriting it into a review, and so there was a little goof up when that happened on this one. So sorry about that. I fixed that for future versions. but so sorry.
Is that the only one that will say contain R?
That's the only section that will say contain R. Now, how about plane parallel to RKN? It doesn't have to contain point R, obviously, because it can't be parallel. But give me one anyway. Give me a parallel plane to RKN.
SPL.
SPL, yeah. Okay. So.
Say LSP, right?
Sure. The order of the points doesn't matter. Say PSL. Can PSM for that matter. Throw an M in there instead of any one of the letters. But just 3 letters for a plane. All right. So naming points, lines, and planes. We're good. Identifying angle pairs. It's huge. Got to be able to do it. Angle 3 and angle 2 are vertical. Did you notice that I gave you kind of a word bank there right there in the question, so you know what the possible answers are? So no one should be coming up with like weird names like name the angle pair. Fred and George. Okay. Couldn't name them that. That would be naming them after the Weasleys, but naming them after the Weasley brothers, twins. Harry Potter reference, anybody? No? Okay. All right. 1 and 4, we're vertical again. 4 and 5. Now again, let's take a look at it. 4 and 5 are 4 and 5. Aha, that's kind of like my funky Z symbol there. So we know that that's going to be alternate interior.
Can we abbreviate that?
You could say alt-int, yeah. But the words are given right there. Don't over-abbreviate because you could wind up, like if you just said interior, that'd be wrong.
AI?
Because no, not just AI. At least alt-int. Okay. 4 and 7, consecutive interior, yep. Yeah, but you're that good. Okay. And then finally, 6 and 2, corresponding. And we said alternate interior angles make the Z shape. Consecutive interiors make what letter? C. And corresponding letters make that F shape. Okay? And sometimes that F is up, down, sideways, whatever. But it serves some people recognizing that that letter helps them recognize the name that goes with it. For some people, that's just even more things to memorize and more confusing, so you don't need to memorize it that way. But if it's helpful for you, use it. All right, find the measure of angle 1 and angle 2. Now, it didn't say this on your sheet, but it will say it on the quiz, and justify how you know, just like we did in the homework. So you're going to have a blank. It's going to look like measure of angle 1 equals, and then reason. And the measure of angle 2 equals, and reason. Yep. And what is the reason? What is the reason? It's an angle pair name plus the word theorem. Okay? So, and again, it's always the angle pair it makes with the given angle, not with angle 1 and angle 2, with the angle that is given. So with the 78. So angle 1 is going to be what measure? What measure? Start by the measure, 78. And corresponding angles theorem. Now, technically, it's corresponding angles postulate, but I'll accept theorem. Postulates are more powerful rules than theorem. Postulates do not need to be proven to be true. We just accept them to be true. Theorems need to be proven to be true. So corresponding angles is technically a postulate, but I'll take it. How about measure of angle 2?
Alternate.
Well, first it's a measure. 78.
Alternate exterior.
And that'd be alternate exterior angles theorem. And again, you can see how I abbreviate and use the angles symbol, use the angle symbol for the word angle. Little shortcuts. Helps you fit in big words in small places. Okay. How about down here? Measure of angle 1 equals 130. Reason? Careful.
No, it'd be
Alt interior angles theorem. And the measure of angle 2? 50 degrees. And reason? Consec int angles theorem. Theorem is THM. Okay? If you want to write out the whole words, it's okay. You're going to have limited space. You have to write small, but I'll read. I've got my reading glasses. I can handle it. Okay? So this is just like what we did in the homework. Angles. Angles. That's what I do. Yep. It's a safe abbreviation. Are the lines parallel? How do we know? Okay. You don't need a full proof. You just need to know, are they parallel or not? And if they are, give the reason why you know. And guess what? If we're going to prove them parallel, we're going to use the angle pair name plus what magic word? Converse. Okay, we're proving the lines parallel, we use the word converse, not theorem. Because we're working backwards. It's the converse of the theorem. So we learned about converses last chapter. So, are L and K parallel for number 12? No, not parallel. Why not? Yeah. These are consecutive interiors, and in order for the lines to be parallel, they'd have to add up to 180. Those add up to 190. That means not parallel. So sorry. Nope, you just have to say not parallel. Nope. How about 13? There, you don't need to because it's not parallel. Okay, these are, but it takes a little bit of work. Okay? And depending on what you do, there are different ways that you could prove this one. Okay? But it's 2 steps. Okay? So first maybe I could do linear pair here and then corresponding. Or I could do vertical angles and then consecutive interior. Or I could do linear pair this way and then alternate interior. Now, the one in the test is going to be more straightforward. Okay? Really, this problem is another one that was a little bit of a goof based on previous geometry books we've worked with. The perpendicular transversal theorem was included in proving lines parallel section 3.3. This book, it actually includes it in the section we're going to learn on Friday. But there actually is a theorem that says if two lines are perpendicular to the same line, then they must be parallel. But we could still do that by using like linear pair here. This must be a 90 also, and then alternate interiors. So we could get there. But on the test, it'll just be a one-step one, I promise. Okay? Question? So we'd say yes, and then the reason why, which here I did linear pair. And then alternate interior angles. Converse. Okay. But like I say, it'll just be a one-step one on the test, I promise. These should be pretty straightforward. What type of angle pair do we have in the top one there? Alternate exterior, which means they must be what relationship in order to be congruent? So 88 equals 2x plus 20. I got to see that, okay? I got to see that setup. Don't just tell me the value of x. I need to see the setup. So 68 equals 2x, and divide by 2, x is 34. How about here? Okay, they add up to 180. So 5x plus 4 plus 7x plus 6, you're right, equals 180. It's 5x minus 4. Okay. So that's 12x plus 2 equals 180. So 12x equals 178. So x equals 178 over 12, which, oh my goodness, that must be wrong because it doesn't simplify to a whole number. We're big boys and girls now. We can have answers that don't simplify to whole numbers. That simplifies to 89/6. And that would be a perfectly fine answer. Now, some people have decimally approximated it, and as long as you go to a couple decimal places, I'm okay with that, but only if you've shown your work up to that point. If you show me that x equals 178 over 12 equals 14.83, it's not exactly right, but it's close enough for what we're trying to do because you've shown me you understand the process. And I'm more concerned with the process than having the solution expressed totally perfectly at this point. There'll be times in the future I'll be more concerned with that. All right, so that pretty much covers it.
Can you go back over 13?
Sure.
I was confused on that one.
This one?
Yeah.
This was not so good. Let me give you an alternate question for that, okay? Let me give you an alternate. Whoa, that's not the line I wanted, but that's okay. I can fix that. Okay. And no, it's double touching. I can actually do that. The smartboard allows double touch.
Yeah, they're not parallel.
Okay. Well, but what if I told you that this angle was 120 and this angle was 120? Are the lines parallel?
Yeah.
What's the reason?
Because they're
Corresponding angles converse. Okay. How about now? Alternate exterior angles converse. How about now?
Be the X. So vertical. No.
Okay. And vertical angles, is that converse? Is that such a thing for proving lines parallel? Is there vertical angles converse to prove? No, there's not. No. They are vertical angles. That is correct. But there's no vertical angles converse theorem for proving lines parallel. Okay? So there, that's probably a better example than the right angle one. Okay? Anything else? All right, let's see if this actually worked.
Wait, were you recording the whole time?
Trying to.